Okay, the first part says use proof by induction to establish that 1 times 3 plus 2 times 4 plus dot 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 plus n times n plus 2 is equal to 1 over 6 times n plus 1 times 2n plus 7. This is a proof by induction. There is like one extra step where they don't give you the summation form of the left-hand side. They put it in a dot dot dot. So it's up to you to actually figure out what the exact form of this thing is. So let's do that first. What we should do is we should say, okay, it's going to sum. Now, the hint that is like most important is you see that the last term is n times n plus 2. And every term is something times that same thing plus 2. 1 times 1 plus 2, and then 2 times 2 plus 2. So we see that it should be I times I plus 2. And then the last thing is to figure out what the range of the summation is. You see that the summation starts from 1 when I is equal to 1. So that should be I is equal to 1. And then it goes up to n. So that's how you figure out, or you convert what they give you in non-summation form into summation form. And it helps a lot to use summation form for the proofs by induction. So I suggest you do that if they don't. But a lot of times they will give you it. Okay. Now let's do proof by induction. So the first step in our proof by induction is to define what you want to prove. So let's say let P of n be the proposition that the summation I going from 1 to n I times I plus 2 is equal to 1 over 6 times n plus 1 times 2n plus 7. Now, in an inductive proof, there are 3 steps. One is the base case, the next one is the inductive hypothesis, and then you do the inductive step. So the first thing we have to start with is the base case, which is P of 1. So that means I just let n equals 1 in my P of n. So if n equals 1, the left-hand side is just the summation I going from 1 to 1 of I times I plus 2, which is just 1, I equal 1, and then I plus 2 is 3. So 1 times 3, which is 3. What's the right-hand side? Well, it's just going to be, well, it's 1/6 n times n plus 1 times 2n plus 7. But remember that n is 1. So it's 1/6 times 1. N plus 1 will be 2. 2n plus 7. And then 2n plus 7 will be 2 plus 7, which is 9. So if I multiply 2 by 9 is 18, and 18 over 6 is 3. So the left-hand side is equal to the right-hand side, as it must be. So thus, P of 1 is true. So this just means that the base case is true. Now we do what's called the inductive hypothesis. And to remind you what that means is we're going to assume that P of k is true. So let's write that down. Assume P of k is true. And now let's write down what that means. Meaning that the summation, let me write that back. The summation I going from 1 to k of I times I plus 2. So wherever I see an n, I'm putting a k now. Is equal to 1/6 times k plus 1 times 2k plus 7. That's the inductive hypothesis, and we're allowed to assume that. What we have to do now is take what's called the inductive step. We have to prove it true for P of k plus 1. So let's prove P of k plus 1 is true. So let's start with the left-hand side. That's going to be the summation I going from 1 to k plus 1 now of I times I plus 2. Now, when you have these summation induction problems, this is like one of the things that's going to be very similar for like almost all of them. When you're doing the inductive step, what you have to do is you have to break it up. Instead of summing from 1 to k plus 1, what you're going to do is sum from 1 to k. Let me make that clear. Sum from 1 to k of I times I plus 2, and then plus the k plus first term. So the k plus first term will mean I put k plus 1 in place of I. So I'll be plus k plus 1, and then times k plus 1 plus 2. So that's just k plus 3. Then the next thing is you use the inductive hypothesis to deal with this. So that's like a real important thing to remember for these summation induction problems. Because like this is like the meat of it. Like in almost all of them, you'll be doing this exact same thing. So, okay. Now I put in this equation here. So that's going to be 1/6 k times k plus 1 times 2k plus 7, and then plus, in brackets, k plus 1 times k plus 3. And now remember, I want to show what this is. Yeah, I want to show that this is equal to the right-hand side with k plus 1 in place, right? What will help a lot is if I could figure out what that is supposed to be, so that I could then manipulate this towards that, right? So what I'm going to say is, okay, I want to show, that's writing it in red here. So I'm going to use this, but instead of k, I'm going to put k plus 1. So it's going to be 1/6 times k plus 1. Then the k plus 1 will become k plus 2. And then the 2k plus 7 will be 2k plus 9. Because it'll be like 2k plus 2 plus 7. And then 2 plus 7 is 9. So I want to show that this thing here is equal to that. So I'm basically just going to make algebraic manipulations to get that. And I mean, for induction proofs, you could always do this. Like it gives you a little hint as to like what you're supposed to do, rather than you just kind of like if you're just left with this, right? Who knows what the next step is? You might multiply this whole thing out, and then what? That's why I think it helps a lot. Like if you have a guide to know like where you want to go. So for example, right, I see in my answer here, there's a 1/6 k plus 1. And both of these have a k plus 1. So why don't I factor 1/6 k plus 1 out? It's equal to 1/6 times k plus 1. And now I'll use our square brackets here. This first term will be k times 2k plus 7. And then here would be, well, I factored out 1/6, so I'd have to put back a 6 there, and then the k plus 1 will come out, and it'll just be 6 times k plus 3. Now what I'll do is I'll multiply out this bracket. So it's with k plus 1. K times 2k is 2k squared. And then k times 7 is 7k. And then plus 6k. And then 6 times 3 is 18. Okay, and then 1/6. I'm going to collect terms now. K plus 1, 2k squared plus 13k plus 18. Okay. So, one thing I just want you to realize is, yes, I'm going to factor this now, but what you should realize is that when you factor it, you have to get these, because that's what's left, and you have to get the right answer at the end. So I know what I'm going to get, but let's just factor it anyway. So you want two numbers that multiply to give 2 times 18 being 36, and then add up to give 13. Well, you could use the final form of the answer to realize that 9 would probably be one of those numbers. So it'll be 9 and 4, because 9 times 4 is 36, and 9 plus 4 is 13. Go 1/6 times k plus 1. So now it'll be 2k squared plus 4k plus 9k plus 18. And then 1/6 times k plus 1. And then here it'll be 2k in brackets k plus 2. And then plus 9k plus 2. And then the last step, let's say, is equal to 1/6 k plus 1. Now if you factorize this, you're going to get k plus 2 and then 2k plus 9. The last thing I would do to make it really clear that this is the thing with k plus 1, it's equal to 1/6 k plus 1. And then here I'll put k plus 1 plus 1. And then here I'll put 2 in brackets k plus 1 plus 7. That's the exact same thing. But it makes it really clear that this here is the same thing as the right-hand side for k, but instead of k, you put k plus 1. So then the last thing is to conclude your proof. So we'll say, thus, we see p of k plus 1 is true. And then what I'll say is, by the principle of mathematical induction, p of n is true for all n. Let me make my n look like an n. P of n is true for all n. So I mean, this is a summation and induction problem. A lot of them are very similar to what I just did. Just the algebra tends to change a bit, but the same structure exists for all of the questions. So I suggest make sure that you're really comfortable with this type of question. Though I would say time it comes more in Unit 1 than Unit 2. Okay. Part B. Use the method of differences to show that the summation r going from 0 to n, 1 over r plus 4 times r plus 5 is equal to 1 over 4 minus 1 over n plus 5. Okay, so let's do this. The first thing is to remember what method of differences is. It's basically saying when you have a lot of things canceling, you could just use the first and last term. That's basically what it's saying, but let's go through this problem. The first thing you need to do is you need to do our partial fractions on this 1 over r plus 4 times r plus 5, right? So let's start with that. 1 over r plus 4 times r plus 5. Well, they already factored it, so it should be equal to a over r plus 4 plus b over r plus 5. And well, one thing is that if you look at this final answer, you could kind of guess what a and b should be, but let's just do it properly. So if I multiply by r plus 4 times r plus 5, 1 would be equal to a times r plus 5 plus b times r plus 4, which is then, now the two ways you could solve this, one is you could like substitute two values for r and figure out what a and b are, or you could do what I'm about to do, which is just say, okay, this is equal to a plus b r, and then plus 5a plus 4b, and then this is 1 plus 0r, so therefore 5a plus 4b should be equal to the constant term, which is 1, and a plus b should be equal to 0. And now I just solve for this. So therefore a is minus b. So if I put that into the first one, minus 5b plus 4b equal 1. So minus b equal 1 or b equal minus 1. And then a is equal to 1. So therefore, all of this implies that 1 over r plus 4 times r plus 5 is equal to 1 over r plus 4 minus 1 over r plus 5. Now I'm going to put this in my summation, right? So now the summation r going from 0 to n, 1 over r plus 4 times r plus 5 is equal to the summation r equals 0 to n, 1 over r plus 4 minus 1 over r plus 5. Now let's write out what the terms look like. It's equal to, well, when r is equal to 0, it's equal to 1 over 4 minus 1 over 5. And then when r is equal to 1, it'll be plus 1 over 5 minus 1 over 6. And then when r is equal to 2, it'll be plus 1 over 6 minus 1 over 7, dot, dot, dot. And then the last term is when r is equal to n. So it'll be plus 1 over n plus 4 minus 1 over n plus 5. And the method of differences, the key observation is that this plus 1 over 5 and minus 1 over 5 will cancel. All of the middle terms will cancel whenever they say do a method of differences. There'll be a plus 1 over 7 right here, and so on and so on. And then this last term will cancel. If you're unsure what cancels, remember they give you what the final answer should be. It's equal to 1 over 4 minus 1 over n plus 5. And you see that the 1 over 4 is the first term, and the minus 1 over n plus 5 is the last term. So that's all that doesn't get cancelled. So you just put O is equal to 1 over 4 minus 1 over n plus 5. So that's how you do this method of differences question. I would say a lot of the time, if they give you the final answer, that's really useful information. Like it'll help you if you get stuck or like you forget, what might need to be cancelled and that kind of thing. Use the final answer to guide you. Okay. Okay. Now let's calculate the partial sum S19 of the series. Well, S19 is just going to be, I just put n equals 19. So just 1 over 4 minus 1 over 19 plus 5, which is just 1 over 4 minus 1 over 19 plus 5 is 24. You just put this in a calculator if you want, or you could be like, well, 1 over 4 is 6 over 24, 6 minus 1, so it's just 5 over 24. Okay, and then the last thing is hence or otherwise, find the sum to infinity. So let's say sum r equals 0 to n. Remember, let's just write over the formula r plus 4 times r plus 5 is equal to 1 over 4 minus 1 over n plus 5. Now, as n goes to infinity, what you have to realize is that this n plus 5 gets really big. So 1 over n plus 5 gets really small. So we say as n goes to infinity, 1 over n plus 5 will just go to 0. So the actual sum will therefore be, that part just drops out. Sorry, let me just make sure. This is at n plus 5 here. So yeah, that part will drop out and it'll just be 1 over 4. So sum r equals 0 to infinity, 1 over r plus 4 times r plus 5 is just equal to 1 over 4. Because, I mean, a fraction with a real big denominator is basically just 0. And if it's just 0, well, then the answer will just be 1 quarter. I mean, this is a real important thing to remember for partial fraction. I mean, method of differences. When you do the method of differences, if you have like a 1 over n in your answer, as n goes to infinity, that'll just be 0. So you could like drop it to figure out what the final answer, the sum to infinity should be.